All right, here we go. Let's do this. We are going to do some sum and difference. So the first thing that we have sketched out for you to refresh your memory are the coordinates of the endpoints on your unit circle based on your reference angles 30, 60, and 45. So you're going to be using those to do some of these sum and difference problems. So if you do not have the printout of your sum and difference formulas, you might want to have that next to you just so you can see where everything's coming from. And we'll go play with some of this stuff. So we're going to use sum and difference to find the exact value. So you're going to need those unit circle values. Now, what you need to do is you need to think, how can I come up with 15 using 30, 45, and 60? So two answers pop up in my head right away, and one of them is the cosine of 15 could be written as the cosine of 45 minus 30. And once you do that, if you look at your sheet, you have the cosine difference formula. And all you would have to do is use it. So we'll start with, that would just be the cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. And now you just have to use your exact values from above, plug them in, simplify, and you're done. So the cosine of 45, we know, is the square root of 2 over 2. The cosine of 30, we know, is the square root of 3 over 2. Plus, we know that the sine of 45 is also the square root of 2 over 2 times the sine of 30 is 1/2. Now all we have to do is simplify from here. So the square root of 2 times the square root of 3 is the square root of 6, and 2 times 2 is 4. Plus the square root of 2 times 1 is the square root of 2 over 2 times 2 is 4. And since we are adding here, you have to remember your rules for adding radicals. You cannot add radicals with different insides. So common denominator is already 4. So our final answer is the square root of 6 plus the square root of 2 all over 4. And that's it. You just have to have your exact unit circle values and your sum and difference formulas. So sine of 75. Why don't you think about that for just a second and see if you can set up the formula. Let's see what we do. So the sine of 75 could be the sine of 30 plus 45. That will give us 75. Now you want to stick to your 30s and your 45s. So what we're going to do here is the sum formula for sines is going to be the sine of 30 times the cosine of 45 plus the cosine of 30 times the sine of 45. Back to your unit circle, we know that the sine of 30 is 1/2. The cosine of 45 is the square root of 2 over 2 plus the cosine of 30 is the square root of 3 over 2 times the sine of 45, which is root 2 over 2. And this should look pretty similar to you. When we multiply those together, we're just going to get the square root of 2 over 4 plus the square root of 6 over 4. And surprisingly, we get the exact same answer as the one before. So we get the square root of 2 plus the square root of 6 all over 4. And the reason that happens is because cosine and sine, if they are complements, so the cosine of 15 and the sine of 75, they're going to have the same value. Okay, that's going to work out when you have complements. The last one is in radians. Well, luckily you know how to work with radians, so this is the same kind of thing. So to use tangent, how are you going to come up with 11/12? Well, you're going to need to think a little bit outside the box here. You can split that up a couple of different ways, but it needs to be able to be reduced. Or in your case, think about multiplying it so you get a common denominator of 12. Because if we look at our unit circle, everything that we have labeled up there is in sixths, fourths, and thirds. So we know we can get to 12 somehow. So if you think about that for a minute, we can come up with the tangent of 3 pi over 12 plus 8 pi over 12. And the reason why we picked those is because it does add to 11/12, but it will reduce to pi over 4 and 2 pi over 3. That's why we want to use 3 pi over 12 and 8 pi over 12, because we can use those. So now, again, all you need is your little formula sheet, and your formula sheet will tell you what to do. So you just have to remember, tangent is sine divided by cosine. So pi over 4 is going to be 1. The tangent of pi over 4 is 1. And the tangent of 2 pi over 3 is going to be negative square root of 3. So now we're going to use our formula. The formula is going to tell us that it's the tangent of pi over 4 plus the tangent of 2 pi over 3 all over 1 minus the tangent of pi over 4 times the tangent of 2 pi over 3. And then again, we're just going to plug everything in. So on the top, we know that this is 1 plus, we know that is a negative square root of 3 all over 1 minus, and then this is going to be 1 times negative square root of 3. And then we just have to simplify from there. So that's 1 minus the square root of 3 all over 1 plus the square root of 3. We are not allowed to have radicals in the denominator. So from there, we're going to multiply the top and bottom by the conjugate. That's 1 minus the square root of 3. And that's going to give us, when we're done foiling, 1 minus 2 square roots of 3 plus 3 all over 1 minus 3, which of course we can simplify to 1 plus 3 is 4, minus 2 root 3 all over 1 minus 3 is a negative 2. We can factor out a 2 from every single one of those parts. So that's going to finally simplify to negative 2 plus the square root of 3. So with the tangents, a lot of time you have a lot of simplifying to do, but hey, we can do it. So we will. All right, so that is a couple of examples of using sum and differences. So let's move on. So now we're going to use sum and difference with other than 30, 60, 90s and 45, 45, 90s. So the first thing we're going to do is we're going to assume that A and B are in standard position when cosine of A is root 2 over 2, sine of A is less than 0, tangent of B is 12/5, but the sine of B is greater than 0. So we have to first draw A and B. So what we're going to do over here is start with our coordinate plane. And the first thing, angle A has a positive cosine value but a negative sine value. So that means we will be drawing this angle in quadrant 3, because that is where sine is negative and cosine is positive. And it says that the cosine has a value of the square root of 2 over 2. So cosine is x, so that's the square root of 2 over 2. And that's going to make this 1. So then all we have to do is use a little bit of either 45, 45, 90, or you could actually use the Pythagorean theorem if you want to find the missing side. Since it's down here, we know this is going to be negative root 2 over 2. And then the next thing we have to do is draw the tangent of B when sine is positive. So tangent's positive and sine is positive, so that means the only place where both of those are positive are going to be up here. And this one is going to say that the tangent of B is opposite over adjacent. So this is 12 and this is 5. Use a little bit of Pythagorean theorem, and we are going to get that that is 13. So from there, all we have to use is our sum and difference formula. So we have the cosine of a plus b. So use the difference, or use the sum of cosine formula, and we're going to use these values. Okay, so the first thing we're going to do is look at our formula, and we're going to say, hey, guess what the cosine of a is? And the cosine of a is going to give us square root of 2 over 2. And then the next thing we're going to do is we're going to say, what is the cosine of b? And the cosine of b is 5/13. And this is going to be minus. And now we need to do, what is the sine of a? The sine of a, opposite over hypotenuse, is negative root 2 over 2. And then we're going to say, what is the sine of b? And we know that b, the sine is 12 over 13. So all we did was use the same cosine sum formula that we used earlier, except for now it's not only our special right triangles. But again, all you have to do is simplify. So the first thing you're going to do over here is multiply those two guys together, and you're going to get 5 root 2 over 26 minus, multiply these two guys together, and we're going to have a negative 12 root 2 over 26, and then we just have to combine those. So that's going to become 17 root 2 over 26. Done. That's it. You just have to make sure you draw these appropriately. And if it helps you, make sure you name them so you don't forget which one is where. So that's it for that. Now I'm going to tell you to pause the video and you try sine of a minus b. So you're going to have to use your difference formula for sine on the sheet and substitute in all your values, and let's see what you can do. Give it a try. If you got negative 17 root 2 over 26, you are good to go. All you had to do is use the formula and substitute in your values and simplify. Proving the trig identity. So we're actually going to prove that the cosine of x minus y plus the cosine of x plus y is equal to 2 cosine x cosine y. And to do that, obviously, we're just going to use our sum and difference formulas. So we start at the beginning. We can rewrite the cosine of x minus y as the cosine of x times the cosine of y plus the sine of x times the sine of y. And now we're going to add, and the cosine of x plus y is going to be the cosine of x, cosine of y, minus the sine of x, sine of y, and of course that's just equal to our right sine of 2 cosine x cosine y. And from there you can see we're just going to take the positive sine x sine y and the negative sine x sine y, and those cancel, and we have 2 cosine x is cosine y's, and 1 plus 1 is 2, so that's just going to give us 2 cosine x cosine y is equal to 2 cosine x cosine y. There you go. A little identity for you. That's it for this. This is Longo, and I'm out. See you, bye.